Here's another problem, and we want to graph this rational function. So the first thing that we want to do is, as always, try to factor. And you'll see why factoring is really important from the very beginning. So let's go ahead and take out an x. We can see that there's a common x here. I can take out an x, and I'm left with x squared minus 1. Be very careful, because usually what people forget is like oops, what did I do? What people forget is that they take out the x and they put a 0 there, or they forgot to put it in the 1. So be very careful with that. Then we're going to do x plus 1. Notice that this x squared minus 1 can further be factored into x plus 1, x minus 1, divided by x plus 1. And what you'll see is that the x plus 1s actually go away. And what I've left with is x minus 1. That's what I'm left with. And you can factor this to really see what this is. You get x squared minus x, which is, in this case, a parabola. So why is this really, really important? Well, the reason why it's important is because what I commonly see is that people think that this is a vertical asymptote, and it's not, because in the end, it ended up canceling out. So when things cancel out like that, we don't have a vertical asymptote. What we have is a hole. So we actually have a hole. The hole is the thing that canceled out. So x plus 1 equals 0 is actually a hole. So at -1, we're going to get a hole, not a vertical asymptote. And now that we're done with finding the hole, the function that we're really looking for is just this. This is what we're looking for. This is what we're going to try to graph. We don't care about this anymore. Okay? This is what we have. This is what we're going to have to work with. Okay? So notice that this, clearly there's no denominator, so there's going to be no vertical asymptote. There's no denominator to look here, so there's going to be no horizontal asymptote, which makes sense, right? Because a parabola does not have a vertical or horizontal asymptote. We can either say no slant asymptote also. This will actually have x-intercepts. What you can do is set y equal to 0 to get your x-intercepts. So you're going to get 0 equals x squared minus x. Well, we can factor this out. And what we're going to get is x equals 0 and x minus 1 equals 0, which x equals 1. So we have 2 points, 0, 0. So it's going to go through the origin, and it's also going to go through x equals 1, 0. So I have 2 x-intercepts. Okay, my y-intercept, I'm going to set x equal to 0. So I'm going to have y equals 0 squared minus 0. You'll see that this is just going to be 0. So I only have 0, 0 as my y-intercept. Okay, so I'm going to go ahead and graph this. All right, so I know it's going to go through 0, 0. I know it's also going to go through 1, 0. Okay, we know that this is going to be a happy parabola. So this is a happy parabola because my number in the, I think I misspelled parabola, but I don't care. The number in front of the x squared is a positive one, so we know it's going to look something like this. Now, what we can do for this type of problem is that we can try to find the minimum value, so this lowest value. And the way that we do that is using x equals negative b over 2a. Okay, so we're going to use x equals negative b, in this case it's -1, divided by 2 times 1. I'm going to get 1/2. Okay, and in order for me to find the y value, I'm going to plug it back into x squared minus x. So I'm going to get 1/2 squared minus 1/2. I'm going to get 1/4 minus 1/2. This is going to give me -1/4. Okay, so this is at 1/2. I'm going to get -1/4. Okay, this figure is definitely not drawn to scale. Okay, and then all we got to do is just draw my parabola. Now we have to be very careful because where was my hole? My hole was at x equals -1. So at x equals -1, I have to be very careful. Okay, so at x equals -1, I'm going to have a hole there. Okay, and if you want to figure out, oh, okay, my parabola is very terrible, but whatever. You get the picture. If you want to figure out what this y value is, what exactly this y value is, plug in the hole, plug in this x equals -1. So if I plug in x equals -1, I'm going to have -1 squared minus -1 This is going to give me 1 plus 1, which gives me 2. So at 2, you're going to see that the hole is going to be there. So my parabola looks kind of weird, but you kind of get the point. This is going to be basically my answer. So this entire thing is my answer. A little ugly. But what I really want you guys to take away from this is that don't work with the original. Work with what you end up with after you cancel out these terms, after you find the hole. Because sometimes you will get a vertical, horizontal, slant asymptote, or sometimes you may not. Okay?